let's look at two more uses of electrolysis. If you remember, we have done under 8.4 electrolysis of brine, and today we will look at two more uses of electrolysis, and in this case we are just actually going to study the electrolysis of copper 2 sulfate solution using different electrodes. The two uses of electrolysis related to this factor of electrodes is firstly refining or purification of a metal. It simply means an impure metal can be purified using electrolysis. And the second is called electroplating. This means that a metal is coated with another metal so as to prevent it from corroding or to give it a better appearance. Let's compare the two types of electrodes. In the first case, we use inert electrodes. What are inert electrodes? Are the electrodes we have been using all along, which is carbon or even platinum electrodes. Are termed inert electrodes because they do not react with the electrolyte. So if we use copper 2 sulfate with carbon electrodes, at the cathode you have copper ions being discharged. Remember, it is copper and hydrogen, but hydrogen is higher than copper. So because of that, copper is being discharged to form copper atoms, and finally copper solid is deposited on the electrode. So we have a coating of copper on the electrode. This is using carbon. What about the anode? At the anode, you have sulfate and hydroxide. Once again, hydroxide ions are chosen because the hydroxide ions are lower in the reactivity series compared with the sulfate. So 4 moles of hydroxide ions will give you 2 moles of water, 1 mole of oxygen, and 4 electrons. So as a result of this electrolysis, using carbon electrodes, what are the products formed? Is copper at the cathode, and at the anode you have oxygen being given off. Now, this will bring us to the fact that there's going to be a color change in the solution. Copper 2 sulfate is a blue solution, but at the end of electrolysis, you are going to see that the blue color fades. Why is this so? Because the concentration of copper 2 ions are reduced as a result of them being discharged. So less copper 2 ions are present in the solution, therefore the solution, the color is going to fade, it's going to get lighter and lighter blue. Now, the other scenario, if you are going to change the carbon electrodes used and replace it with copper electrodes. Now at the cathode, there is no change actually. Copper is once again deposited, so you have copper ions gaining electrons to form copper. And visibly, you can see that the copper electrode is going to become thicker. At the anode, a reaction that is going to take place is entirely different. Because copper is no more an inert electrode, but is an active electrode in this case, it is going to dissociate and form ions. In other words, the copper is going to go into solution. And as a result, at the end of electrolysis, what you're going to see is the copper electrode is going to become thinner. Okay? So, at the cathode, it's going to become thicker because copper is being deposited. And at the anode, it's going to become thinner because the copper is going to go into solution. Now, if I ask you what happens to the color of the solution, perhaps you can guess. The electrodes at the copper anode, ions are being formed. At the cathode, the ions are being discharged. So there is no net gain or loss. This means that the intensity of the blue color does not change. Okay. Based on what we have actually looked at, the uses of electrolysis of copper 2 sulfate is firstly to refine or purification of copper. Say if you're given a piece of metal copper that is impure, you need to refine it or purify it. How would you go about doing it? Simply, the anode has to be made the impure. Copper has to be made the anode. Then the cathode has always to be a piece of the pure copper. And the third condition is the electrolyte has to be a dilute solution of copper 2 sulfate. It cannot be zinc sulfate, it cannot be magnesium sulfate. It has to be copper 2 sulfate. Of course, it can be copper 2 nitrate, but what's important is the copper ions must be present. Then the copper at the anode, as we have seen in the earlier slide, is going to dissolve in the solution, and the impurities will be deposited at the bottom, and a pure layer of copper is going to be formed at the cathode. So the same concept of using reactive electrodes is used in electroplating as well. So we actually are moving on from refining copper to electroplating, which is the second use. Let's look at the diagram for the purification of metals and copper, namely. So just now I was mentioning to you the requirements. This diagram explains it all. You have at the anode the impure copper. It serves as the anode, okay? This is very important that you remember. Always the impure metal serves as the anode. Then what you have at the cathode is the pure metal, and in this case is copper. And the solution has to be a solution of copper ions. It can be copper 2 chloride, copper 2 nitrate, copper 2 sulfate, a dilute solution. And you can see here that the impurities are going to be deposited just below the anode. Now what happens as a result of this? The copper, the pure copper is going to be deposited on the cathode, and this piece is going to become thicker. This will slowly diminish in size and become smaller. Okay? So this will be the purification of metals. Let's look at the second use of the copper 2 sulfate solutions electrolysis, which is electroplating. What is electroplating? It means using electricity to coat one metal with the other. Why do you need to coat a metal with the other? It's simply to make the metal look more attractive, and in the second case, to prevent corrosion. For example, steel bumper cars are coated with chromium, and steel cans are coated with tin to prevent it from rusting. And also the cheap metal jewelry are often coated with silver, simply because you can't use silver for the whole thing, it's too expensive. But if you coat it, then it gives it a good finish. So electroplating is used for two purposes. One, to make it look more attractive, more saleable. The second one is to prevent corrosion. Okay, let's look at an illustration of how electroplating is done. Say for instance you want to coat a spoon that is made of iron. Iron spoons are not so attractive, okay? But silver spoons are very attractive. So how do you go about it? Simply by applying the principles that we learned. So when silver has to be used as the anode. So a thin piece of silver is used as an anode. Then whatever object we need to be electroplated, in this case a spoon, has to be used as a cathode, and it has to be totally dipped in a solution of silver nitrate. So if you're going to coat it with silver, the electrolyte has to be silver nitrate. Okay? Let's look at the reaction that's going to take place at the anode. The silver is going to be an active electrode, so it is going to go into ions. Forms ions. Can you see that? Ag is going to form Ag positive. And this Ag positive will then move to the surface of the spoon, which is serving as a cathode. And at the cathode, what you see is the silver ions going to receive the electrons. Where do the electrons come from? They obviously come from the external circuit, where the silver has been losing electrons. So it will receive the electrons and be deposited as silver. So after electrolysis has been carried out for a while, you will have a thin layer of silver being on the surface of the spoon. There are several conditions for this electroplating to be done successfully. One is you need to have an ammeter and control the current to be small. And of course you need to have a mechanism to rotate the spoon at all times so that the coating will be even. Here we have given you two other metals that are normally used for electroplating. That is chromium and nickel. Say if you want to coat something with chromium, then you need to use chromium nitrate as electrolyte. Then you have to use chromium, the pure metal chromium as the anode, and whatever you need to coat it as a cathode, and the solution must be chromium nitrate. Okay, so for nickel, I think you can make a guess. You make the necessary changes. So the three metals that are normally used for electroplating will be silver, chromium, and nickel. Even copper can be used. Okay, what I have here just two examples of what you see as the product of electroplating. Okay, so here the metal that is to be electroplated is chromium. Chromium gives a good shine, and it also prevents corrosion. And most jewelry like silver is not 100% silver, but it is coated in silver. So this would bring us to a close about the uses of electrolysis. Thank you.